Okay, welcome to this fascinating problem concerning a square of side 20 with 4 quarter circles drawn in it to make this overlapping pattern. We've got to find the ratio of the white area here to the shaded area. Okay, now what I've done is I've recreated the shape here, but I've labeled and I've noticed 3 distinct areas. Okay, I've got 4 copies of area A, which is the shaded area. Okay, I've got 4 copies identical of area B, which are these bits here, and I've got 1 of area C, which is the bit in the middle. Okay, now I'm going to make 3 distinct equations relating to certain shapes I can make from this square. The first one is simply an equation for the total area of the square in terms of A, B, and C. So that's what I'm going to do first. So it will be 4 lots of A plus 4 lots of B plus 1 lot of C, and I know that that equals the total area of a square 20 by 20, which is 400. Okay, that's my first equation, and I'm going to call it equation 1, like this. Okay. The next thing I'm going to do is I'm going to take out one of the quarter circles. I'll do this one that has a center bottom left. So it's this quarter circle here that I'm highlighting. Okay, and you can see that the area of that is made up of a certain number of A, B, and C. Okay, but it's also 1/4 of a circle which has a radius of 20. Okay, so you need to form an equation linking those, and that will be as follows. The total area inside this quarter circle is A plus A, 2A. Okay, so it's 2A plus I have 3B in there, and I also have C. And I know that that's the same as 1/4 of a circle of radius 20. So it's 1/4 of pi r squared, and in this case it's 1/4 of pi times 20 squared. Okay, so in other words it's equal to 1/4 of 400 pi, which is 100 pi. Okay, and I'm going to label this equation 2. Okay, now thirdly I'm going to work out an equation for a different area, and it's the area that I'm going to highlight now using by moving my yellow boundary a little bit. Okay, from where it is now I'm going to change it to be this area here, which I've also drawn to the right in a separate diagram. Okay, now as you can see that area is made of A, 2 B's and a C. Okay, but it's also made of an equilateral triangle T and these 2 sectors or segments rather, which I've called S. Now it's possible to work out the area of these 3 things here. And we know this is an equilateral triangle because if I swung this line around here, when I get to this point here, I'm the same distance away from this point as I am here. In other words, I'm 20 units away when I'm here from this point and 20 units away from this point. So I know it's an equilateral triangle, therefore it has angles 60 degrees and 3 equal sides of 20. Okay, but I've also got these 2 curved sections from round here and here. Okay, so I need to work out the total area. Now I'm going to start with the triangle, and that I'm going to do first. And the triangle area T, okay, is half base times height, but I don't know what the height is. I only know that it's 20 sloping. But I can use Pythagoras' theorem, and the question actually hints that Pythagoras theorem might be useful. So how do we use it? Well, we recognize that we've got a right angle triangle. We know a short side of 10 and a long side, a hypotenuse of 20. So the height of this, if I just call this h for height, okay, the height down the middle of that triangle is equal to the square root of the long side squared minus the short side squared, one of the short sides squared, okay, which is that. Now that is the square root of 400 minus 100, which is equal to the square root of 300, okay, and the square root of 300 is, I'll just write it like that first, it's actually the same as the square root of 100 times the square root of 3, and the square root of 100 is 10. So it's 10 root 3 in what we call simplest form. Okay, now that is the height of the triangle, but we want the area. Well, the area, so I'm going to put here triangle area, okay, is a half base times height. Well, the base of the equilateral triangle is 20, so it's a half of 20 times the height, and the height is 10 root 3. Okay, if we put all that together and simplify it without evaluating it as a decimal, just leaving it in what we call surd form, simplified surd form, half of 20 is 10, times 10 is 100. It's 100 root 3, okay? That is the area of T, the triangle T, okay? So I'll just put T there to show what that equals. Okay, now what about these two sectors, which I've called segments rather, which I've called S? Right, well, I could work out the area of the sector, right? That's the triangle and the segment. So I could work out this area here quite easily. If I just take that part and then go straight down here, that is the same as 1/6 of the circle it comes from. And the reason it's 1/6 is because we know that this here is 60 degrees. Okay, because it's an equilateral triangle, and 60 is 1/6 of a circle. So that shade, that yellow area there, is 1/6 of pi r squared. Okay, so S plus T, okay, is equal to 1/6 of pi times 20 squared, okay, because we're dealing with circles of radius 20, which is 400 pi over 6, which is 200 pi over 3, just halving the numerator and denominator. Okay, so that's S plus T. Okay, so I need to take away T, which is 100 root 3, to get S. So S on its own is equal to 200 pi over 3 minus the triangle, which is 100 root 3. Okay, and if I simplify that, well, that's it. That's S. I'll just leave it in that form for the moment. Okay, so my area that I'm interested in is made of S plus T. All right, that's the total area inside this here, which is made of A and 2 B's and a C. Okay, so let's make an expression for that. In fact, we can now go back over here and we can say that A plus 2B, so I'll put that here, a plus 2b plus c, okay, which is this area in here, okay, is made up of, I'll just write it for the moment as t plus 2s, okay, and now I'm going to tidy this bit up. That's an s, not a 5, okay, and I'm going to write this out. Now this looks very complicated to start with, but it soon simplifies. So t is 100 root 3, okay, that's here. Now s is that, but I've got two of them. So because I've got this s here and this s here. So that is 200 pi over 3 minus 100 root 3 times 2. So in fact it's going to be 400 pi over 3, okay, just doubling each term, minus 200 root 3. And if I simplify that further, I get that a plus 2b plus c is equal to, now I've got 100 root 3 take away 200 root 3, which is the same as minus 100 root 3 plus 400 pi over 3. So I'll write it as 400 pi over 3, okay, minus 100 root 3. Okay, and that is my expression for a plus 2b plus c, which I'm going to call equation 3. Now, the next stage is to recognize that you now have 3 distinct equations, right? 1, 2, and 3. Each equation contains 3 unknowns, a, b, and c. That usually means it's possible to find unique values of a, b, and c that solve those 3 equations. And we call it solving them simultaneously. Now this in itself is going to be quite a challenging exercise, so we're going to make a second video that will follow this on to the conclusion. I'm pausing this one now. Have a look at this, reflect on what we've done, and we'll solve these 3 equations in the next video.